Hello. So today we are going to talk about functions. So first, when you talk about functions, so functions are when you have two sets. So let's say we have a set A and a set B. And when you have numbers, let's say in set A, 1, 2, 3, and set B, let's say 4, 5, 6, okay? Then I'm gonna match numbers from A to numbers in set B. So let's say 1 to 4, 2 to 4, and 3 to 5, let's say, okay? Then how I matched these numbers between two sets, that is a function. And let's say function f, okay? And in terms of notation wise, f of 1, so if I get number 1 from set A, then that became number 4, or match it to number 4 in set B, right? So if it's f of 2, then that's also 4, and f of 3, then that's 5, okay? Then these numbers from the first set, so in this case 1, 2, 3, so these 1, 2, 3 are called the domain, okay, the domain. Then how about those two numbers 4 and 5 from the second set that are matched by 1, 2, 3 from the first set, and those are called the range. So the range is the numbers that are matched by the left set, okay? So 4 and 5, okay? And when you talk about functions, so first, when you talk about domain and range, it can be many numbers, okay? Not just like 1, 2, 3, or 4, 5. Maybe it's not like countable like that. Maybe it can be really, really a lot. So it's better to use interval notation sometimes. So what I'm saying is, let's say your domain is all the numbers from 1 to 10 even, okay? But there are many, many, many numbers, infinitely many numbers between 1 and 10. Because it's not just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It can be, but for example, there is 1.1 or 1.11 or 1.111. So to include all those numbers between 1 and 10 inclusive, one notation you can use is x is between 10 and 1 and including them, okay? So that's greater than or equal to and less than or equal to, okay? So which means we include those numbers as well. So x is between 1 and 10 including 1 and 10, okay? And another way to show this inequality, so the interval of x, is we can use this square bracket and put 1 and 10. So what it means is exactly the same as here. So greater than or equal to 1 and the square bracket and 1 are the same thing. And less than or equal to 1 and this side of a square bracket of 10 are the same thing, okay? So if you want to describe your domain is between 1 and 10 inclusively, you can just say either x is between 10 and 1, or you can just give this interval notation for the domain, okay? Then how about the range? So range is similar. So if let's say your range is from 2 to 4 and including 2 and 4, okay? So any number between like 2, 2.1, or 3.9, 4, all those numbers are range, let's say, okay? Then again, you can use the same notation like this, or you can just say square bracket 2 and 4 and square bracket, okay? And what if your domain or range or anything you want to show your interval does not include the endpoint? Like let's say you want to say x is between 1 and 10, but this time you want to include 1, but you don't want to include 10, okay? Then in that case, you can use square bracket and 1 and 10 and you close the parentheses. And this 10 and parentheses is same as just strictly less than, okay? Strictly less than, and the parentheses work as the same. So for the range part, if you want to write, let's say, strictly greater than 2 and less than or equal to 4 this time, okay? Then how can you write that down? So it's gonna be parentheses 2 and 4 square bracket, okay? Then it means it's strictly greater than 2 and less than or equal to 4. Okay? And one more thing about the interval notation is, what if your domain is all real numbers? So we're going to talk about number system later, but all real numbers means just it can be any number, like any integer, any irrational number. So for example, like including all the numbers like 1, half, or 0.333 forever, or pi, or square root of 2. What is the domain includes all these numbers? Then we call that all real numbers. And there are many ways to write all real numbers. So one fun way is you can use this set notation with R, an extra line. It means it's a set of all real numbers. Or you can use x is less than positive infinity and greater than negative infinity. So this is one way some books use. And here what you need to notice, we don't include infinity because infinity is not a fixed number. So we can make it equal to infinity, okay? Because it's just going forever, right? You cannot just grab a number and say that's the infinity. So as you can see, it's strictly less than and strictly greater than. And as you can probably guess at this point, if you want to use this interval notation for describing all real numbers, then you can use a parenthesis, negative infinity, and infinity parenthesis, and then these three all mean the same thing, okay? Then what if you want to say so let's say the domain of a function is all the numbers less than or equal to 4, let's say. Then you can just simply say x is less than or equal to 4, or if you want to use this interval notation again, the less than or equal to is again, what is that? That's square bracket and 4, right? Then how do we close this? How do we complete this interval notation? Then we put negative infinity and strictly greater than to the left side. So these two notation will be the same. So for example, if you want to say your range is greater than or equal to 2, let's say, okay? So your range is greater than or equal to 2. So this is one way to notate that. Or another way is you can put square bracket, which means greater than or including 2 and to the positive infinity. And we cannot include infinity, so we put parentheses here. Okay? So those are the interval notations we are going to use to describe some parts of the function. So now, let's look at this function here. So yeah, that's not too fancy. So here, I try to emphasize these points. So when those points are shaded, it means those points are included. Okay? And when I put empty circle here, it means that function is not defined there. So what I'm saying is if I call this function as f, okay, then f of 0 is not defined at 2, but it's defined at 4, okay? Another way to say, when x is 0, where should I look at? Not the empty circle. I need to look at the shaded circle, okay? So f of 0 is 4. Okay, f of 0 is 4, not 2. Okay, then if you look at this weird looking function, what do I want to talk, or what do I want to learn from it? So first one is, let's talk about the domain and the range, okay? So domain is the possible value or assigned values of x's in the function, okay? Then how can you tell what kind of numbers are included in the domain of a certain function? So usually how I suggest is you look at the graph of the function. Of course, sometimes the graph is not given, or without graph you need to think, but especially when the graph is given. So check how far left the function can go and how far right the function can go, okay? So in this case, the far left point the function can reach is when x is -3, right? Here. So -3 is the far left point that function can reach. and the far right point the function can reach is positive 3. So I can say the domain of this function is negative 3 to 3 and inclusive. So I include the negative 3 and include the positive 3. Then how about the range? To tell the range of the function, usually I suggest when you have a graph, how far, so how up the function can go and how below, down the function can go, okay? So in this case, so this function can go up, up, up until where? 4, right? And how much can the function go down? Until negative 4, right? And since those are shaded circles, we should include those points. So the range is from negative 4 to positive 4, right? Inclusive. Okay? So now, the next part of the function we are in, or next characteristic of this function we are looking for, we are interested in learning is which portion or which interval is increasing and which interval is decreasing, okay? So a function is increasing or increasing in an interval means the function generally has this kind of slope, okay? So when a function has this kind of slope, we say that's increasing. When a function has this kind of slope, we say that's decreasing. And I say kind of because maybe it can be a curve, so like this or this, right? So in this case, a function is increasing. This case, a function is decreasing, okay? So it doesn't have to be a line. It can be a curve, it can be some weird shape. But still, increasing and decreasing is generally, is it right up or right down, okay? So now, if you look at this function is going right up from here to here, right? From axis negative 3 to axis 0. This function generally has right up shape. So the interval where the function is increasing is from negative 3 to 0, okay? And when you say increasing, decreasing, usually we don't include that end point. So you can just say the function is increasing where x is negative 3 to 0, okay? So this kind of like blue, purple portion of the function is increasing part, okay? So then where is it decreasing? So if you scroll up here from axis 0 again and to axis 3, it's kind of going down, right? Right down. So that's the decreasing portion of the function. So from where to where? From axis 0 to axis 3, right? So that's the decreasing portion. So we can say the function is decreasing from 0 to 3, okay? And next part of the characteristic we are looking for is positive portion and negative portion of a function. So if you look at this function, some part of the function is above the x-axis and some part of the function is below x-axis. So the portion of the function that's above the x-axis, we call that the function is positive there. The portion where the function or graph is below the x-axis, we say the function is negative in that portion, okay? So let's look at the positive portion first. So from here to here, okay? So this much. As you can see, the portion of the function is above the x-axis, right? So where is it? That's from here, which is negative 1, to here, where x is 2. So from negative 1 to 2 is where the function or the graph is above the x-axis, okay? So that's from negative 1 to 2, where the function is positive, okay? Then where is it negative? When the function is here to here, right? So here is where the function is negative, but we have one more portion. From here to here, the function is negative 2, right? But be careful, for example, when x is exactly negative 1, the function is not negative, not positive, it's just 0, right? So that's why when I talked about positive portion, I didn't include the negative 1 or 2, okay? So if you look at this left portion where the function is negative, that's from when x is -1 to x is -3. But in this case, I'm not going to include -1, but I'm going to include -3. Why? Because when x is -1, y is exactly 0, so that's not negative. But when x is -3, y is -4, so it's still negative. So negative portion is first, where x is -1 or less. Sorry, just less than -1. We are not including -1 again, okay? And -3 or greater. So this portion is the square bracket. And there's one more interval here where the function is negative, right? So that's when x is greater than 2 and less than or equal to 3, okay? So x is greater than 2 or less than or equal to 3 is another negative portion of this function. And the next characteristic we want to know about the function is x-intercepts and y-intercepts. So x-intercept is where the function intersects with the x-axis, and the y-intercept is where the function intersects with the y-axis. So as you can see, there are 2 points where the function intersects with the x-axis. One is at -1, the other is at 2. So the x-intercepts are, I forgot, okay, -1. So when x is -1 and y is 0, be careful, this is not interval notation. This is not, it doesn't mean from -1 to 0. It means x is -1, y is 0. So this is typical xy coordinate, okay? And the other point was x is 2, y is 0, right? Then now let's find the y-intercept. So the y-intercept is where the function or the graph intersect with the y-axis. So at this point, when x is 0 and y is 4, is where the function intersect with the y-axis. So be careful at here, because this is an empty circle, this function is not defined. Or easy way to say, it's actually not hitting the y-axis exactly, okay? So this point here, when y is 4, is the y-intercept. So the y-intercept is where x is 0, y is 4. Okay? Finally, the maximum and the minimum. So maximum is basically the highest point that's defined by the function. So in this case, the highest point of the function is here, right? Which is y is 4. So when you talk about maximum or minimum, that's basically the y value, okay? Of course, maybe the question or your SAT or ACT problem can ask you, where is the maximum? When they ask where or when, that's usually about the x value. But when they ask what is the maximum, what is the minimum, that's usually the y value, okay? So the highest point is when y is 4. So that is the maximum of this function. So maximum is 4, okay? And the minimum is the lowest point of this function. So it's not here actually, it's here, right? This one is lower than the other point. So this point is where y is -4. So the minimum is -4. Okay? So today we learned briefly about most crucial parts of properties of functions and characteristics of function. So hope it helped. So please do the homework and see you next time. Okay? Bye.